Hi everyone, thank you for attending our revision session today. Okay, let's wait another 2 or 3 minutes for other students to join us. Okay, sorry about the technical issue earlier. Okay, so we were supposed to have a revision section last week, and then due to some like technical problems on my side or from our school side, so I couldn't join the Zoom meeting. And then same problem happened to us today. So we are a bit late, but don't worry. We should be good. Okay. Okay, maybe we can slowly start now. Okay, so let me share my screen first. Okay, so this is you probably will have here I'm using the digital campus. I think for I think you use Moodle version, okay? But all the contents like I'm talking about today should be the same, okay? So this is the ST1215. Okay, so for the revision. First of all, let me talk about the exam. Okay, so let me just share another thing, share the one of the past paper, and then just give you a sense that how the exam would be like. Okay. Okay, so let's look at this example paper. Okay, so the exam gonna be you will find this paper at the end of your course as the past paper sample examination paper. Okay, I think one paper is enough. Okay, so your exam gonna be 3 hours. Okay, and then you will have 5 questions to answer within 3 hours time. Okay, you need to answer all the questions. And then each question will be 20 marks. Okay, and then normally we will for each chapter that we covered in this course, we're going to like create 1 or 2 questions or 1 or 2 small questions from each chapter. Okay, so for example, question 1 here is something to do with the discrete random variable, and then the all sense of probability, and then 1B here is something to do with set theory. Okay. And then 2A here, this is something to do with the probability again. So you will that I think later I will go through the chapter by chapter in detail later with you. Okay, just to give you an idea like what are the topics that have been covered in your course. Okay. Yeah, so yeah, so this is how the exam question will be like, and then each sub questions basically for each chapter we're going to create some like exam questions. Okay, so for example, 3A here is something to do with maximum likelihood estimation. Okay, but in this case we didn't ask you to estimate the maximum likelihood estimator, but yeah, we ask you to derive the joint probability density function. Okay, for the maximum likelihood estimation, we call such function as the likelihood function. Okay, and then 3B here is something to do with the multivariate random variable. And then this type of question is very important. Okay, so I can promise you that definitely will be one question come out in this format. Okay, so make sure you go through a couple questions like this in a similar style before the exam. Okay, so these type of questions are not difficult, but the calculation is quite is a bit like complicated, not say complicated, but it will be very time consuming for you to do the calculation. Okay, and then you only have 3 hours for for the exam to complete 5 questions. Okay, so of course you don't want to spend too much time on it. Okay, so in order to do well for this type of question is to go through a couple questions before the exam. Okay. And then 4A, so from question 4 onwards, yeah, it's to be something to do with the statistical inference part. Okay, so for example, 4A here, we learned what we so this is one example to show you what kind of proof question will come out in your exam. Okay, so this is the one this is the mean square error of the estimator. Okay, so we define the mean square error of the estimator in this way. Okay, and then you need to be able to derive the proof to decomposite this mean square error into the sum of the variance of theta hat and then the square of the bias theta hat. Okay, so make sure you go through this proof. Yeah, it probably will come out in your final exam. Okay, so this is one type of question that will ask you to prove something. Okay, right. So this means that you need to, when you go through your course material for your revision, make sure you derive the proof that's covered in your course material. Okay. And then for 3B, not 3B, 4B is something to do with the maximum likelihood estimation. Okay. So you for your course, you learn 3 estimation methods. One is the method moment estimation. The next one is the maximum likelihood estimation, and then the third one is least square estimation. Okay, so all these 3, not say all. Okay, so I can say the method moment estimation and maximum likelihood estimation have like very high chance will appear in your final exam. Okay, and then for the least square estimation with something like this, is something to do with the so normally we use the least square estimation method to help us to estimate the parameters for the linear regression model. Okay, for example, for this question, we'll give you some like linear regression model like this, and I would like you to derive the least square estimators for alpha and beta. Okay, so yeah, so should be for the least square estimation, we normally combine it with the linear regression type of question, and then ask you to derive the least square estimators. Okay, one of the example question you can check out. You can check out this question. Okay, for this question, it's not the typical like typical exam style question that will come out for the linear regression model. Okay. Later I will come back to the linear regression chapter. Okay, so and then for question 5, it will be definitely would be something about not say that question 5 would be okay, so something about hypothesis testing will appear in your exam. Okay, so whether it will be the text for the for one mean or the difference of mean or the variance, not sure, but yeah, definitely would be one of the questions from the hypothesis testing chapter come out. Okay, so later I can show you there's one table that you need to memorize for your before your exam. Okay, so basically we have a table for this course material. We summarize all the common test statistics in one table for you. Okay, so make sure you remember this table before the exam. Okay, so I will show you which table I'm talking about later. Okay, so yeah, so these questions, first of all, it start with the confidence interval. Okay, and then the last one is about the statistic hypothesis testing for the variance. Okay, and then the last question is the linear regression model. Okay, so definitely will be one question from the linear regression chapter. Okay, and then you might think that most of you find it this chapter is complicated, but it's actually is one of the easiest question that you could see from your final exam. Okay, why is not? Because you have a formulas that you can use. You don't need to remember the memorize formulas for the linear regression model. Cosine formula will be provided to you for the exam. But what you need to know is that you need to know how to apply the formula, okay, to carry out the calculations. Okay, so I will show you the formulas later. I will show you the formulas later to just now you can just get an idea that what are the formulas that will be provided for your exam. Okay, and then there's one thing is missing here is a novel table. Okay, so I think this paper is an old paper. Okay, so it basically includes all the important points that all the possible questions might come out. Similar style question might come out in your final exam, but something is missing, which is a novel. Okay, a novel table. Thing that we might ask you to, we might give you some information and ask you to construct 1 week or 2 week a novel table. Okay, so I will come back to this later. Okay, so this is just a like very brief like guidance to you, like just to get a sense like how does the final how will the final examination paper be like. Okay, so it'll be 3 hours and 5 questions. Okay, and then all these 5 questions, so each sub questions basically come from all the topics that we covered for ST1215 course. Okay, so now let's go to let me just go through chapter by chapter now. Okay, so just 1 second. Okay, so yeah, so I think you are using Moodle. Okay, so you in your case, it probably look the surface the interface look a bit different than me, but all the contents that I'm showing you now should be exactly the same. Okay, it just in this case I'm using the digital campus, and then some of you might use Moodle, so you probably see the different surface as I have now. Okay, but the contents should be the same. All right. So let me just go from the first chapter. Chapter 1 is about data visualization and the descriptive statistics. Okay, so I don't think that anything gonna come out from this chapter for your final exam. But the reason why I put this chapter here is just to give you an idea now how we can use what is the statistics and how we can use the statistic in real life, and then what is the let's say wait just 1 second. Let me see. Let's go from the home. Okay, yeah, and then just 1 second. Yeah, and then just get a sense that what are the descriptive statistics, mean and variance, mode, how we can calculate all these descriptive statistics. Okay, and then understand what is the skewness of distribution. Okay, so basically, chapter 1 is just all about like all the basic knowledge of statistics that you might learn already before you study this course in your high school. Okay, so the real things come from start from chapter 2. Okay, probability theory. Okay, so for the probability theory, what are the key takeaways? Okay, so the key takeaway is set theory. Okay, so for the set theory, we have unions of sets, intersections of sets, unions and intersection of many sets, complement, probability properties of a set operators. Okay, so on your notes, okay, so make sure you go through this property of set operators. Let me just open and then let you see what do I mean. Okay, and then the other one is the further properties of set operators. And the last one is mutually, what does it mean when we say these 2 events are mutually exclusive? Okay, so these are the important parts from chapter 2. These are all these formulas. So basically everything that we summarize in blue color, something like this. So these are important. Okay, so it might be we also have further properties of set operators, okay? So all these things are important. Why is that? Because we probably will give you one question and then ask you to derive the proof to show that, for example, show that event A and event B are independent or something else, okay? And then you need to I understand what does it mean when we say two sets are A and B are mutually exclusive. Okay, so this is one of the key takeaway, and then which is the set theory. Okay, yeah, it will be one small question, one sub question, very small question come out for the set theory. Okay, so in order to do well for this small question, make sure you go through the property of set operators, further property of set operators, and then understand what is the mutually exclusive event. Okay, we probably will ask you to state the definition of mutually exclusive events. Okay, and then for the and then now this come to a very important one, the oceans of probability. Okay, for the past few years, sometimes we ask students to state the definition of oceans of probability. Okay, so we have three oceans of probability. I would recommend you to memorize these three oceans of probability. Okay, who knows? Probably will ask you to state three oceans of probability again this year. Okay, and then for the oceans probabilities, we're going to use again and again later on in our course, which I will show you later with some example questions. Okay, so let me just close this. Okay, so this is the very brief summary of chapter 2. Okay, and then it come to, so chapter 2 is quite long. Okay, it start with the set theory, and then we have the oceans of probability, three oceans of probability. And then it reached to we have the third part of the chapter 2, which is a classic probability and accounting rules. Okay, so what is the key takeaway from this one? The key takeaway is if I give you a probability question, and then you need to, of course, you need to count events. Okay, and then you need to identify whether you're going to count events with replacement or without replacement. Because for the different type of scenario, we have different formula to use, right? So we have permutation, combination, okay, two formulas. So make sure you understand these two formulas, okay? And then there's some example questions here, example. So make sure you go through all these example questions to understand different type of counting rules. Okay, so this is a chapter 2, and then in your course material at the end of each chapter, we also give you some like homework questions or live session questions to practice. I can say all these questions are very close to the exam style questions. Okay, so if you understand all the questions that your class teacher covered in your live session, you should be pretty good for the exam. Okay, so you don't have to search for additional questions to study for your final exam. All right. And then, yeah, all the examples we include in course materials are important. Okay. And then yeah, you should have a similar, similar thing, similar material as I have. Okay, so for the course material, we definitely include enough questions for you to study. Okay, so this is chapter 2. Okay, so now come with chapter 3, random variables. Okay, so here you're going to learn what is the definition of what is the random variables. Okay, and then you're going to learn discrete random variable. What are the discrete random variable? So the discrete random variable are the random variable that can only take possible values as 0, 1, 2, 3, or the integer values, right? And then after that, we learned what is the continuous random variable. Okay, so continuous random variable means that the possible value that this random variable can take is continuous. Okay, For example, okay, so what is the key takeaway from this chapter? So key takeaway from this chapter, basically, we just try to educate you what is the definition of a random variable, what is the discrete random variable, what is the continuous random variable. Okay, and then the main takeaway is that you should know how you can calculate the mean, variance, and moment generating functions for both discrete and continuous random variable if I give you a distribution function. Okay, later on we can work through one example in detail later. Okay, and then it come with so there's some questions you can practice. Okay, and then chapter 4. It comes with the common distributions of random variable. So in chapter 3, you understand what are the random variables. And then in chapter 4, we introduce some common distributions that we often use in our real life of random variables. For the discrete random variable, so what does this mean? This means that all the common distributions covered in chapter 4, you need to memorize it. Okay, so you need to remember its form, memorize it for your exam, except normal distribution. Okay, all right. So for the common distributions of random variable, for the discrete random variable case, we have Bernoulli distribution, very important. You need to remember its distribution function, okay? Binomial distribution and Poisson distribution, okay? And then after that, we know we learned the Poisson approximation of binomial distribution, okay? And then there's some other discrete distributions, which I don't think you need to remember it for your exam, okay? But for the Bernoulli binomial Poisson, okay, so you need to memorize these 3 discrete distributions for distribution function for your exam. All right. And then for the continuous distribution, okay, continuous distribution, we have a continuous uniform distribution, exponential distribution, okay, and then for the normal distribution, okay, so the normal distribution you don't need to remember its distribution function, but for the exponential uniform distribution, you need to remember its form, okay, so you need to remember what are the mean and the variance, okay, for the common probability distributions, okay, and then for the normal distribution, yeah, if you have a additional capacity in your brain, I will recommend you to memorize it because yeah, it's quite useful. Okay, so the reason why the normal distribution is so useful because we can use it for the central limit theorem. Okay, and then we can also have a normal approximation of a binomial distribution. Okay, and then the reason why the normal distribution is so useful because it has one like very useful property, which is a symmetric around mean. Okay, and then statistical table. Okay, so for the normal distribution, make sure you know how you can read the statistical tables. Okay, why it is important? Because in your second half of your course, for the statistical inference, you're going to use a statistical table very often. Okay, so make sure you know how you can read the statistical tables. All right, and then okay, so these are some like examples, work examples, questions, practice questions. I will recommend you to go through, just work through all these questions before the exam. Okay, so these questions are basically most of all the questions that we covered in our course material. Basically they are the past exam questions. Okay, I saw someone raise their hands. Yeah, you can just unmute yourself if you want to ask me any questions. Okay, so if you would like to ask me any question, you can just unmute yourself, okay? All right, and then chapter 5, multivariate random variables, okay? So very important, okay? So definitely would be one question, at least, let me see how many marks. Yeah, would be one question, at least 15 marks from chapter 5. Okay, so what kind of question will come up? I will give you example. I show you the example earlier from the past paper question. Okay, so can I show you this one? Okay, so this is a very classic exam question that we often have in the final exam. Okay, so this is would be the question that you probably will see in your final exam. We'll give you a joint probability table, and then from the joint probability table, we ask you to determine the marginal distribution for random variable x and then y, and then we'll ask you to compute the expected values, okay? And then the follow-up question will be, we'll ask you to calculate the covariance of the random variables of x and y, okay? And then also do some calculations. So yeah, you can take you definitely can find these two questions in your course material, okay? So make sure you go through this question and these questions. So this question is a different way, okay? So instead of giving you the joint probability table, so in this case, we'll do it other way around. We'll give you the marginal distribution, okay? We'll give you the marginal distribution of x and y. And then we define the new random variable x and t. And then after now, we'll ask you to construct the table, the joint probability distribution for x and t. Okay, so this question I think is one of the most challenging question you could see for this chapter. Okay, so I can say if you fully understand these two questions, you should be good for your final exam for chapter 5. Okay. All right. And then chapter 6. So after chapter 4. So chapter 5, 6, 7, 8, 9. I can say all these chapters are quite easy because you can just apply the formula directly. Okay. So what do I mean? I mean that wait, where's my chapter 6? Oh, so this okay, chapter 6. Okay, chapter 6 about sampling distribution of statistics. Okay, so what is the key takeaway from this chapter? So the key takeaway is that you should understand, of course, you up to chapter 6, I think you've already understood what is the normal distribution. Okay, and then how you can standardize the normal distribution to a standard normal distribution. Okay, and then how you can, so the important thing is this part, okay, the common sampling distribution, okay? So you should know how you can apply the formula to help you to construct a chi-square distribution using the standard normal distribution, okay? And then you should be able to read the statistical table for the chi-square distribution. Why is that? Because we need it for the hypothesis testing later in chapter 8, okay? And then student t distribution, okay? So how, in this case, we can construct a student t distribution using standard normal distribution and the chi-square distribution, okay? And then, yeah, you should know the formula that's which formula that you need to use to construct student t distribution. And the F distribution is the ratios of, we can construct the F distribution using two independent chi-square random variable, right? So yeah, so this basically is the key takeaway, the common sampling distribution. So chi-square distribution, student t distribution, F distribution. Okay, so make sure you fully understand this chapter, especially for this common sampling distribution. Okay, so if you don't understand this part, you will be in trouble to understand the later chapter. Okay, for the confidence interval, hypothesis testing, level table, and linear regression. Okay, so this is very important for the second half of your course, okay, for the statistical inference. All right, and then if you want to, there's some questions I find it very good to fully understand what I was talking about. Okay, so the internet is a bit slow, just 1 second. Okay, something like this, okay? So make sure you find a couple questions to practice. Some question like this to practice, okay? So if you are perfectly okay with this type of question, then then it will show that you have a good understanding of normal distribution, chi-square distribution, student T distribution, and F distribution. Okay, so make sure you go through all the questions not to be covered in your live session or in your class by the class teacher for chapter, what chapter is it? For chapter 6. Okay, and then come back to us if you need the support to understand this type of question. Okay. All right, let's go back. Sorry, we need to scroll all the way down now. So chapter 8. Okay, so this is chapter 6. And then for chapter 7, point estimation. Okay, so in chapter 7, we cover 3 estimation method. Okay, and then definitely will be test. Okay, method moment estimation, likelihood estimation, maximum likelihood estimation, and then least square estimation. Okay, so make sure you understand these 3 estimation methods, and then go through some questions for these 3 estimation methods. We have plenty of examples available for you to study for each estimation method. Okay. All right, there's nothing much. And then let's move on to the next one. Hypothesis testing. Okay, so hypothesis testing. So in this case, all you need to know is that, okay, so one thing I forgot to mention is, I think the challenging part of hypothesis testing is to know how you can calculate type 1 error, the probability of type 1 error, the probability of type 2 error, and the power of test. Okay, so these 3 things are they are very challenging. I think it's quite challenging to calculate these 3 things. Hopefully, we're not going to put this kind of question in your final exam. Okay. So the table I mentioned earlier for the hypothesis testing. Okay, so for hypothesis testing, you have a normal test. It depends if you know in this for the normal test. If you want to carry a hypothesis test for hypothesis testing for the population mean, okay, if you know what the variance, in this case, you can use the normal distribution to carry out the hypothesis testing. If you do not know the variance, we're going to use the student T distribution to carry out the hypothesis testing, right? And then there's one table I mentioned earlier. Basically, we summarize all the, something like this. Wait, let me just open up all the tables and then explaining to you. Okay, so these are the tables that's what I'm talking about, okay? You will have this summary table, the test for mean and the variance in a normal distribution, okay? So in this case, we assume that if we carry out hypothesis testing for mu, we assume that sigma square is norm. Okay, so we're going to use the normal distribution to carry out the hypothesis testing. If the sigma square is unknown, in this case, we're going to use this test. Okay, so this test statistic as to carry out the hypothesis testing, which is a student T distribution. Okay, and then we're going to use a chi-square distribution to the chi-square, a random variable which follows the chi-square distribution to help us to carry out the hypothesis testing for the variance. Okay, so this table you need to memorize, and then there's another table which is the test for 2 normal distribution. Okay, so in this case, we would like to carry out the hypothesis test for the difference of the mean. Okay, so you have a 2 group. You would like to see like whether there's a difference between the mean of these two groups. Okay. And then we're going to separate into two cases. One case is that sigma, the variance, the population variance is known. And another case, the population variance is unknown. Okay, so for the case that population variance is known, we're going to use the normal distribution. Okay, and then if the population variance is unknown, we're going to use the student t distribution. Okay, and then there's the last one is about the ratios between two variance, the ratios of variance. Okay, so we're going to use the F distribution. Okay, so these two table, make sure you put it in your brain, okay, before the exam. Okay, so definitely would be one or two questions come out in your final exam. Okay, so you yeah, and then I think for the past years, we also ask you to derive the proof. Okay, for example, to show that in this case, for the case that sometimes we ask you to derive the proof to show the test statistic. Okay. I think in your course material, we have the detailed working show you the proof for the different test statistics. Okay, so yeah, so basically the idea is that not only my recommendation is that you should not only just like remember all the formulas for the test statistics. Okay, you at least need to learn like how you can derive the proof for the test statistics. Okay, sometimes I think for the past one of the past years, we put one question, something like show that the test statistic t is equal to either one of is equal to this. Yeah, for the case that the population variance is known, and then we would like to carry out the hypothesis test for the difference of mean. Yeah. Okay, so this is the hypothesis testing chapter. Okay, and then now we're going to move on to the next one, ANOVA. Okay, so chapter 10, ANOVA table. Okay, so it's an easy chapter. You're going to have a formulas. We're going to give you formulas to you to construct the ANOVA table. Okay, so the key takeaway is that the main takeaway is in chapter 10, you should be able to know if I give you one question and I ask you to construct the ANOVA table, then you should be able to know how you can construct the ANOVA table from scratch. Okay, one way and two way. Okay, so what is the one way and two way ANOVA table, and then what is the type of question might come out in your final exam? I will give you one example here. Okay, so if you look at this question, okay, so this is not a good question. Let's look at this one. Okay, so this is a very classic exam question that you might have in your final exam. We will give you, either we will ask you to construct, we give you some like data, and then we'll ask you to construct the one-way or two-way ANOVA table from scratch. Or we'll give you a one-way or two-way ANOVA table like this, which is incomplete ANOVA table, and then we'll ask you to fill in all the gaps. Okay, so you need to start from degree of freedom. Okay, so there's a formula. There's formula on your note in your notes which I want to show you. Is it something like, oh yeah, this one. This is one way, and then we're going to see the one way. Okay, so let's see the one way first. Where's the table? Ah, I can't find the table, but oh yeah, so this is the table. Okay, so this is a two-way table, and then we also have a one-way. Okay, so let's you can figure out, you can find out the one-way table by yourself. Okay, so I will recommend you to memorize this whole table. Okay, for example, how you can calculate the degree of freedom for the row factor. Degree of freedom on row factor is equal to R minus 1. For the column factor is equal to C minus 1, and then residual is just equal to the product of these two. Okay, and then also you need to get the formulas that you need to know how to use the formulas for you to calculate B row, B column, the sum square, mean square, and F. Okay, so you have a formulas given to you. Formulas are given to you to calculate sum squares. I will show you later. What are the formulas that we will give to you for your final exam? Okay, so basically you need to memorize the layout of this two-way ANOVA table. Okay, and then for the one-way ANOVA table, similar thing, you're gonna have you need to, so this is the okay, so this is the one-way ANOVA table. Okay, again, you need to memorize the layout of the table. Okay, and then you need to understand what is the hypothesis testing behind this ANOVA table. Why do we need to construct a one-way ANOVA table? What is the p-value? And then we have a F statistic. Why do we need to use the F statistic? What kind of hypothesis testing we are carrying? For this case. Okay, so we don't have much time to go through this type of question. So I will leave it to you to go through some questions for the one-way or two-way ANOVA table. I think you have plenty of example here. Okay, and then let's go through the last one. Linear regression. Okay, so linear regression chapter, it looks quite complicated, it looks long, but all you need to know is I can say, so all you need to know is that you need to understand for the simple linear regression model, what are the assumptions behind it, okay? And then for the linear regression model, how we can estimate the parameters, let's say alpha, beta 0, beta 1 for the simple linear regression model, okay? Yes, so basically we have two ways. We have two methods that we can use to estimate the parameters for the simple linear regression model. One is the least square estimation method that we cover in the previous chapter. And the other one is the maximum likelihood estimation. Okay, and in order to use the maximum likelihood estimation to estimate the parameters for our simple linear regression model, we need to pose some assumptions on epsilon I. So we need to assume that our epsilon I follows the some like normal distribution. Okay, if you oppose this assumption, then we can derive the maximum likelihood estimator for beta 0, beta 1. Okay, so basically that's the main idea, main assumption. Okay, so I will recommend you to go through this question. Okay, so some question like this in detail. Okay, so basically this is just the one of the classic questions that you might see in your final exam. It looks complicated, but you have all the formulas ready for you. All you need to do is that you need to all you need to do for your revision is to go through the questions with the formulas and then you need to understand how you can use the formulas to carry out the calculations. Okay, so basically the linear regression model, I can say the questions for the exam question for the linear regression chapter, and the exam question for the multivariate random variable chapter, and the exam question for the ANOVA, one-way or two-way ANOVA, for the ANOVA like chapter, they are quite easy. Why is not? Because you have formula that you can use in your exam, and I will show you which formula I'm talking about. Okay, it should be this one. Okay, so you're going to have something like this as a which is the formula sheets. Okay, so you're going to have this formula sheet in your in your final exam. Okay, so first of all, you'll be the simple linear regression model. Okay, and then Here we give you the formula to estimate beta 0, beta 1, variance of beta 0, variance of beta 1, covariance of beta 0, beta 1. And then the estimator for the variance of epsilon I, and then some the regression ANOVA, okay? And then this quite long, and then some hypothesis testing, that you confidence interval, that you might need to like construct for, let's say, beta 0 plus beta 1x. Okay. For in this case, sometimes we will ask you to carry out the hypothesis testing. Okay, for, let's say, for beta 0. So in this case, yeah, so in this case, what you can do, yeah, basically, that the formulas are here, okay, but still is not very straightforward to apply the formula, okay, because you still need to like decompose the formula into a simpler way, such that in order to complete the calculation. For example, sum square, total sum square. Okay, so this is the formula I'll give to you. Normally during the calculation in your exam, you need to decompose this one as a sum of yi square minus ny bar square, something like this. Okay. Yeah, so basically, yeah, make sure you go through some questions like this before the exam, just to get yourself familiar with the calculations. Okay, and then you can come back to us if you need the support with understanding the calculation. Okay. All right. And then the formulas that you have for the one-way and two-way ANOVA table. So these are the formulas. Okay, so yeah, so formulas are here. All you need to do is like, and then the one-way or two-way ANOVA table type question definitely will come out in your final exam. And then all you need to do is that you need to memorize the layout of the table for one-way and two-way ANOVA table. Okay, and then you need to remember how you can calculate the degree of freedom. Okay, for according to my experience, most of students they got the degree freedom wrongly. Okay, so if you get your degree of freedom wrongly, this means that your later calculation gonna be wrong as well. All right. Okay, so these are the brief summary of what you've done from us, and then what are the key topics for the exam for each chapter, and then also show you what is the formula sheets and you have in your final exam. Okay, and then for the next step, I will go through some questions. Okay, and then basically I will go through some past exam question just to give you an idea, like what kind of solution that you need to provide in your final exam. Okay. Wait just 1 second. Okay, so it's not sure this. Just 1 second. Okay, so you should aim to have as detailed working as possible for your final exam. Okay, so here I'm going to show you just give you some examples here. Okay, so we won't be able to have enough time to cover all the questions from each chapter. Yeah, but the reason why I provide some example question here is just to give you idea like how you can write like what is the standard of the solution that we are looking for the final exam. Okay, what is the format of the solution? Okay, so let's look at question 1. Okay, so for this question, what do we have? We have is a 4-mark question. Okay, so basically you should be able to do it quickly within couple minutes time. Okay, so in this question, what do we have? We have the random variable x has a Poisson distribution with the probability of x equal to 1 equal to probability of x equal to 2. Okay, and then we need to determine the mean and the variance of x. So in this case, what do we know? We know that our x follows the Poisson distribution. Okay, let's say with parameter equal to lambda. And then we know that for the Poisson distribution, mean and the variance they are equal, and then it is equal to lambda. But what in this case, we don't know what is lambda equal to, right? But we know that probability of x follows the Poisson distribution. This means that probability of x equal to x. In this case, it should be equal to e the power minus lambda the power of x over x factorial, and then this is for x equal to 0, 1, 2, 3, etc. Okay, and then now we need to find a way to figure out what is our lambda equal to. Okay, we are given that probability of x equal to 1 is equal to probability of x equal to 2. Okay, so probability of x equal to 1, what do we have? This is equal to e the power minus lambda the power of 1 over 1 factorial. Okay, and then we have probability of x equal to 2. This is equal to e the power minus lambda. Okay, e the power minus lambda the power 2 over 2 factorial. Okay, so what we can do here, we can equate them together. We have e the power minus lambda over 1 factorial equal to e the power minus lambda the power 2 over 2 factorial. Okay, and then we can cancel out e the power minus realize my this handwriting is not good, minus lambda. So we can cancel our e the power minus lambda, and then we can get our final solution. Lambda is equal to 2. Okay, this means that this is not the end of question. We need to write the conclusion. So hence we have expectation of x is equal to variance of x. This is equal to 2. Okay, so this is the end of the question I. And for question II, simple. For probability of x equal to 4, all you need to do is just to plug in the formula. Okay, so equal to e the power minus 2 to the power of 4 over 4 factorial. And then use your calculator. This is equal to 0.09. Okay, so I forgot to mention, do not forget to bring a calculator with you for the exam. Okay, so you're allowed to use the calculator. All right, now let's look at question B. Suppose that commercial airplane crashes in a certain country occur at the rate of 2.5 per year. Question I, is it reasonable to assume that such crashes are Poisson events? Briefly explain. Okay, so in this question, it tells you the knowledge about of the Poisson assumptions. Okay, so in this case, for the Poisson assumptions, the events need to be independent, and then the rate of event is need to be like constant. Okay, need to remain constant. Okay, so in this case, yeah, we can say yes, it satisfies Poisson. Why is not? Because crashes are independent events, and the crash rate is likely to remain constant. Okay, it's likely to remain constant. It does not mean that it definitely will remain constant. It just says that it has high chance to remain constant. Okay, and then for II, what is the probability that 4 or more crashes will occur next year? Okay, so what do we need to do? What is the probability we need to figure out in this case? In this case, we can let X be the number of crashes in the year, and our X follows the Poisson distribution with the lambda equal to 2.5, okay, which is given by the question. Okay, and then we need to figure out what is the probability of X greater than 4. Okay, so the probability that 4 or more crashes will occur. So in this case, probability of X will be greater than or equal to 4. Okay, and then this will be equal to probability of X equal to 4, and then plus probability X equal to 5, plus probability X equal to 6, etc. The calculation will be too long, but we can do it in a different way using one of the oceans of probability, which is the sum of the probability is equal to 1. Okay, so this will be equal to 1 minus probability of X less than equal to 3. Okay, and then this should be equal to 1 minus sum from X equal to 0 all the way to 3, e the power minus 2.5, 2.5 the power of X over X factorial. Okay, and then the next step, just use your calculator. You can get your final answer as 0.2424. Okay, so now come with the third question. What is the probability that the next two crashes will occur within 3 months of one another? Okay, so this is one important question, something to do with the waiting time. Okay, so for the Poisson distribution, if we have like events follows the Poisson distribution with a fixed rate. So in this case, the interval between two events, it will follow the exponential distribution with the same rate as well. Okay, so let's say, so this means that if we let y be the interval, let y be the interval in this case in years between the next two crashes. In this case, we have while y follows the exponential distribution with the rate equal to 2.5. Okay, and then we need to, what is the probability we need to calculate? We need to calculate probability that the next two crashes will occur within 3 months of one another. Okay, so we need to calculate probability. The 3 months is a quarter of a year. Okay, so we need to calculate probability of y less than equal to a quarter, which is 0.25. Okay, actually, whether you put an equal sign or not, it doesn't really matter, because in this case, y follows the exponential distribution is a continuous random variable. Okay, and then this, it will be equal to the integral from 0 to 0.25, and then what is the exponential distribution? So it's lambda times e to the power minus lambda y. Our lambda is equal to 2.5. Okay, so it'd be 2.5 times e to the power minus 2.5 y dy. Okay, and then quickly do your calculation. This will this integral should be easy to compute. Okay, should be equal to e to the power minus 2.5 y from 0 to 0.25, and then quickly do your calculation. There should be equal to 1 minus e to the power minus 0.625. Okay, and then use your calculator. You can get your final answer equal to 0.4647. All right, so this should be a simple question. Okay, so the only challenging part is this, the third part. We need to use the fact that if you have an event follows the Poisson, the number of events happen independently follows the Poisson distribution, and then in this case the waiting time between two events, the next two events should follow the exponential distribution. Okay. All right, and then let's look at this question. Okay, so Uh, this question, you will again is a very classic exam style question. Okay, so in your exam, we probably will give you a probability distribution that you haven't seen before, haven't seen before, and I will ask you to derive, what is the moment generating function. Okay, so let's see how we can do it. Okay, so first of all, what do we need to do? We need to now show that its moment generating function is something like this. Okay, it's equal to 1 over 1 minus t the power of 3. Okay, so first step, let's try to write down the definition of the moment generating function. The definition of moment generating function is equal to expectation of e the power of tx. Okay, so this is the definition of the moment generating function. Okay, and then the next step, which formula we need to use, it will depend on like whether our random variable follows the normal follows is a discrete random variable or continuous random variable. Okay. So in this case, we can look at the possible values of our random variable. Our possible value of our random variable x is greater than or equal to 0. So in this case, it's a continuous random variable. Okay, so this means that we need to use the integral to compute this expectation. Okay, then this would be the integral from 0 all the way to infinity e the power tx, and then times the probability density function, which is x e the powers minus x dx. Okay, and you have two options. So let me just combine the exponential term together. Okay, so if you combine the exponential term together, we have x times e the powers minus x bracket t minus 1 minus t. Okay, so you have two options. Option one, which is very very like option one. Okay, option one, you can just use the integration by part formula to compute this integral. Okay, and then the option two, which is the smarter way, is to try to construct a new construct a probability density function that we know we can compute the mean, we know the property, and then we can compute the mean or the other thing directly. Okay, so in this case, if I look at something like this, okay, if I look at this term, this look like this a bit like part of exponential distribution. Okay, so if I can construct exponential distribution with something like this, okay, and then my x times the exponential distribution. In this for the exponential distribution, the possible value is greater than or equal to 0 as well. So if this is the PDF of exponential distribution, then our x times this PDF, and then we compute the integral, simply will just it will be just the mean of the exponential distribution, right? So if we look at this term, we can do a side calculation here. Okay, so if I let my x follows the exponential distribution, what is the rate? You can look at this 1 minus t. Okay, so we can let our rate become 1 minus t. And then in this case, we can write the PDF of our x as 1 minus t times e the power minus x brackets 1 minus t. Okay, and then this is for x greater than 0. Okay, so this tells me that in order to utilize this exponential distribution, we need to introduce this additional term here. Okay, this term here, 1 minus t, to complete the PDF of the exponential distribution with parameter equal to 1 minus t. Okay, so what I'm going to do now, I'm going to introduce these terms. I'm going to introduce this term inside the integral. okay? E to the power minus x, 1 minus t dx, okay? So this is the additional term I introduced in 1 minus t, and then y is not this whole thing here. It will give me give me the x follows the exponential distribution with the parameter equal to 1 minus t. Okay, since I introduced this additional term, but I want to keep this equality sign holds. I need to divide this term as well. Okay, so we divide 1 minus t. Okay, now we have this just a PDF of the exponential distribution. Okay, and then this random variable x. Okay, so in this case, we can straight away you can write down this integral here is actually the formula for us to compute expectation of x, where our x here follows the exponential distribution with the parameter equal to 1 minus t. Okay, and then for the exponential distribution, this is the exponential distribution is under the list of the common probability distribution for the continuous random variable. So this means that you need to memorize its probability distribution function and mean and variance. Okay, and in this case we can just write down the mean for the exponential distribution directly. We can just write it down directly without proving it. Okay, so expectation of x in this case, it will just equal to 1 divided by 1 minus t. Okay, and then this complete the proof to show that the mean, the moment generating function in this case is equal to 1 over 1 minus t squared. Okay, so we complete the proof. All right, and then the second part of the question, we need to figure out the expected value of x. Okay, the expected value of x by definition is equal to the first derivative of the moment generating function at t equal to 0. Okay, so the first step, let's try to take the first derivative of our moment generating function with respect to t. Okay, so if you take the first derivative with respect to t, it will equal to 2 times 1 minus t, the power of minus 3. Okay, and then you're going to let t equal to 0. We're going to have expectation of x. It will be equal to 2. Okay. All right, so this is example to show you that we will give you some like unseen probability distribution function, and then ask you to derive the MGF. Okay, then after now, once you have an MGF, you should be able to know how you can derive the moment from the moment generating function. For example, expectation of x, this is the first moment. Okay, and then the reason why moment generating function is so useful is because we can use the function to generate any moments that we like. For example, if you take the first derivative and instead you let x t equal to 0, you will get the first moment, which is the population mean. Okay, and then if you take the second derivative with respect to t and you let t equal to 0, you will get the second population moment. So with the first population moment, the second population moment, we can calculate the population variance. Okay, and if you want to go higher, the third population moment, you take the third derivative with respect to t, and then let t equals 0, you get the expectation of x to the power 3. Okay, so in this case, you can calculate the skewness, yeah, something like that. So that's why the moment generating functions are like very useful. Okay. All right. So the next question. This question is about counting. Okay, so when you need to, we give you one question, and then when you read the information, then you need to calculate some probability. When you calculate probability, before you calculate the probability, we need to like count the number of events. Okay, so you need to determine whether you should use permutation formula or combination formula. Okay, so we're going to skip this question. Okay, you have multiple similar questions in your in your course material. Okay, so let's go through the next question, which I think is more important. Okay, so this question is about the total probability formula. Okay. Okay, so total probability formula is important. Okay, so I forgot which chapter it is. I think it's chapter 2. Okay, it's belong to chapter 2. I think I forgot to mention this. So total probability formula is important. Yeah, just go through like a couple questions. Okay. So in this case, you can simply, for this question, you can simply apply this total probability formula directly to help you to do the calculation. Okay, but I'm not going to go through this because I want to go through another like tricky question. Okay, which is this one. Okay, so in this case, we are given this probability distribution. Okay, and now we need to show that expectation of x is equal to 1 minus pi divided by pi. Okay, so let's try to do this question together. Okay, so first of all, let's write down the formula that we need to use to calculate expectation of x. Okay, so whether we need to use the integral or summation sign, we need to see whether the random variable is discrete or continuous. Okay, so in this case, we look at the possible values for the random variable. So in this case, the possible value of x are 0, 1, 2, 3, etc. So this means that it's a discrete random variable. So this means that we need to use the summation here to help us to calculate expectation of x. Okay, so the expectation of x should be the summation of x times the probability distribution function of x over all possible value. Okay, so in this case, the possible value of x is start from 0 all the way to infinity. Okay, and then we notice that when x equal to 0, everything is just equal to 0. So this means that we can simplify our summation as x equal to 1 all the way to infinity, x times 1 minus pi, the power of x times pi. Okay, and then the next step, basically is quite is a very like we're going to use a very classic trick. Okay, so we will have something like this. What we're going to do, because from our original question here, our x, the possible value of x start from 0. Okay, and then when we calculate the summation, basically we eliminate the case that when x equal to 0, because when x equals 0, whole thing is equal to 0. So our summation is start from 1. Okay, so normally we will try to, the next trick we're going to use, and we're going to, the next approach we're going to use is that we're going to use the change of variable to rewrite this summation start from 0. Okay, so we're going to use the change of variable that we're going to let y equal to x minus 1. So why I use this one, y equal to x minus 1? Well, it's not because when x equal to 1, we will have our y equal to 0, right? And then when x equal to infinity, x infinity minus 1, our y will just equal to infinity as well. Okay, so we can use this. When we can let y equal to x minus 1. And then in this case, our y, the possible value for y would be from 0 all the way to infinity. Okay, so this means our x is equal to y plus 1. The next step, we're going to replace anything with x with y. Okay. Okay, so now we rewrite the summation. We're going to replace x with y. So x equal to y plus 1. So this means that our y will start from 0 all the way to infinity. Okay, and I'm going to x is equal to y plus 1 m times 1 minus pi, the power of y plus 1 pi. Okay, and then the next step, what I will do, I will take out the constant 1 minus pi, and then sum from y equal to 0 all the way to infinity, and then y plus 1 1 minus pi the power of y pi. Okay, so the next step, what I will do, I will try to decomposite this summation term. Use y equal to 0 all the way to infinity, y times 1 minus pi the power of y times pi. And then the second term of the summation is simply sum from y equal to 0 all the way to infinity, 1 minus pi the power of y and pi. Okay, so don't forget the big bracket here. Okay, so now you might notice something interesting here. Okay, so here, this is the probability distribution function. Okay, if you compare this probability distribution function with the one that we have from original question, we just, instead of using x, we use y. Okay, and then the possible value of y starts from 0 to infinity. So basically, we have exactly same probability distribution as the one that we have for the question, right? So in this case, this simply means that this is sorry. So this is simply is the sum of the probability, okay? So according to one of the OCNs of probability, this will simply just equal to 1. Okay, sum of the probability is equal to 1. And then this summation here, this look like the formula that we have earlier, right? This one is the same as the formula we wrote down initially to calculate expectation of x. Okay, so in this case, this is expectation of y. Okay, but x and y are the same in this case. Okay, so we can just let this thing equal to expectation of x. Okay, so everything is just the same. We just replace. If you compare these two formula here, this one I circle, these two formula I circled, these two summation I circled in red here. Okay, so basically is equal to expectation of x. So now let's tidy up everything. If you tidy up everything, we'll have a 1 minus pi times the expectation of x plus 1. Okay, so this is what we have. And then if you summarize everything together, we have expectation of x is equal to 1 minus pi times expectation of x plus 1. Okay, so what we can do, we can rearrange everything, and then we can show that expectation of x will just equal to 1 minus pi divided by 1 minus pi, and then summarize it, simplify it, it will equal to 1 minus pi divided by pi. Okay, so we complete the proof. All right, so this I found these questions very nice, very useful question. Okay, so normally when we ask you to show something like this, you're gonna use some trick like this. Okay, so this make sure you understand this question because in this question first of all, we need to know that you need to use a change of variable to rewrite the summation. Okay, and then the next step, you should be able to identify that you need to decomposite this summation into two summation. Okay, and then you use the fact that the sum of the probability equal to 1 to get this the second summation equal to 1, and then you should be able to recognize the formula that we use to compute the expectation of a discrete random variable. Okay, all right, so make sure you take a screenshot of this question with my solutions here in case you don't have the same questions. In case you don't have the same questions in your online material. Okay, I think you should have a similar question. You should have the same question on your online material. Yeah. Oh, if you don't have, it's fine. You probably have a similar one. Okay, and then so this question and these questions and this one, the moment generating function, we use a similar trick. Okay, it's a similar trick that we use. Okay, but instead of in this case is the for this case is a continuous random variable, right? And then for this case is a discrete random variable. Okay, so both question we use the similar trick to compute to compute, let's say, moment generate function or expectation. Okay, expectation of x. Okay, so the next question is about multivariate random variable from chapter 5. Okay, so I'm not going to go through this question with you. Okay, so you just all you need to do is just go back to your online course material to go through like question 2, question 1, 2. Okay, at the end of chapter. Okay, and then come back to me or your class teacher if you need the support with understanding the solution. All right, so this should be all I would like to cover for today's revision section. Anything you would like to ask me regarding the exam or revision? Yes, you all good? Okay. So if you're all good, we will end our session today, and then good luck for your final exam. Okay. Right. Bye. For the recording, do you have I think let me ask the team, okay, to tell you now where you can where they will post the recording. They should post the recording in Moodle, okay, in your online course. Okay. All right. Thank you. Okay, bye.